Question 30. Sketch the graph of y equals 3 to the x. This is an important graph. 3 to the x. The thing to note is the base is bigger than 1 here. So when we have a base bigger than 1, it is an increasing exponential graph. Notice our variable, increasing exponential. I don't think I spelled that right, but that's okay. So any graph where the base is bigger than 1 kind of goes like this. It's asymptotic with the x-axis, and it passes through 0, 1. So this is y equals b to the x, where b is greater than 1. So let's do this quite quickly. I prefer to start at 0. So 3 to the 0 is 1. 3 to the 1 is 3. And then 3 squared is 9, which we can't fit on here. 3 to the negative 1. Just remember 3 to the negative 1. We could write that as a reciprocal 1/3. So we want to go 1/3 of the way up. And if we remember that, 3 to the negative 2 is 1/9. So it's, realistically, it almost looks like it's on the x-axis at this point. So in order to graph this, here's what we have. So, make my points bigger there. So it's important to note, and some people don't draw this in, but I like to put it in, that we have a horizontal asymptote right on the x-axis. So our x-axis acts as a horizontal asymptote. So I think this is all we need for the first question. Now for the next question. Explain how the graph of 3 to the x can be used to sketch the graph of y equals log base 3 of x. So this is an explain question, so we want to use words. Okay, so how can we use 3 to the x to graph y equals log base 3 of x? Well, these graphs are related because they're inverses of one another. So let's state this. The graph of y equals log base 3 of x is the inverse of y equals 3 to the x. To sketch y equals log base 3 of x, we will switch. So to sketch y equals log base 3 of x, switch the coordinates of each point. So in other words, x comma y, and the inverse graph will be y comma x. And as we know, that's the same as doing a reflection over the line y equals x.